Hello, dear students. Today we are going to discuss our second lecture, that is Corporate Financial Mathematics 1. Okay, as you can see from this outline, where we will start from time value of money, then we will simple interest rate and compound interest rate. You can memorize that classification in mind mapping. So we will use future value mean compounding and present value of a single cash flow, and then future value and present value of variable cash flow in variable cash flow. Then after that we will discuss equal cash flow, that is annuity, and then we are going to discuss deferred annuity. Okay, so simple cases we are dealing in week 2. Okay, first thing first is the time value of money. Okay, so the time value of money concept says that a dollar today is not equal to dollar after 10 years. Why? Because with time it loses its value. When I say value, it means its purchasing power, right? Its purchasing power. So it loses its purchasing power, and this purchasing power is affected due to interest rate. Okay, when the interest rates go high, our purchasing power goes down. So that's why we don't know about the future, what will happen about to the interest rates. So that's why the purchasing power of the future dollars would be lower than today's dollar. So given this actually underlying factor, we are going to classify into simple interest rate, okay, simple interest rate and compound interest rate. So that is actually the basis of discussion. Now, okay, this is just for your understanding. When we will discuss time value of money, we have to show a timeline. Okay, so that is called a timeline. If you see, this is a timeline, and we have zero mean it is today. You are standing here, you are normally making your decisions here. Okay, and the tick marks mean period 1. I'm saying period, not year. Okay, period could be monthly, quarterly, semi-annually, okay, daily. So period 1, period 2, 3, 4, 5 and 6. These are different periods. Okay, so when we will move across this period, we think that the closer we are with the subsequent period, it means the value would be, this value would be higher than this value would be higher than this value. So with time actually the money loses its value. So these tick marks show the period, the start. This period means the start of year 1. Okay, so period 1. This is the end of period 1. So here when we will move from here, so it will be start of period 2, but this shows the end of period 2. Okay, this is the start of period 3, and this would be the end of period 3. This is start of period 4, end of period 4, and so on. Okay, but remember this is for when we are when we say that these tick marks, actually these tick marks show the end of the period. Okay, so time 0 is today, the end of period, the end of year 0, beginning of the year 1. So this is the beginning of the year 1 or the period 1. Time 1 is the end of the period 1, I would say. Okay, or the year 1. Time 1 is the end. This shows the start of the period, this shows the end of the period. Okay, representing various time periods, so they show the various time periods. Just change the label from year to month if monthly. So that's why we are not calling it as year, we are calling it as periods. Okay, so periods can be yearly, monthly, quarterly. Okay, so this timeline actually would help you to calculate actually the present value or the future value correctly by specifying the questions requirement. So why do we draw the timeline? Just to show that with time the money loses its value. Why does it lose value? Because of the interest rate. Okay, so interest rate can be divided into two classifications: simple interest rate and compound interest rate. So what is interest rate? By the way, this is a rate at which you are here your current consumption, and this is your future consumption, future and present consumption. Okay, so this is actually a rate at which you can exchange your current consumption with the future consumption. Okay, so for instance, if you say you have $100 today, but if you will reach at year 1, so and with this 100 you can buy a one t-shirt. Okay, so you can buy a one t-shirt, so your current consumption is one t-shirt. But when you will reach at year 1, maybe if you have 100, you cannot buy a one t-shirt because it got expensive or your purchasing power went low. So this new t-shirt is for $105 now. Okay, so it means now you are, if you want to now you can exchange your 100 today with 105. Okay, because they both have the same purchasing power. So what is the difference? Difference is due to this 5. Okay, so now 100 today is actually equal to 105 for tomorrow. So just to balance your purchasing power. Okay, so you see a reward for foregoing the current consumption and taking risk, or it is actually the exchange of your current consumption with the future consumption. Okay, so interest is usually expressed as rate per annum. It is normally expressed as per annum. For instance, 5% per annum, which means you will get $5 in interest per year because it's per annum for investing 100. So it means you are going to get extra 5. So they are this is a very simple concept. So we can classify the interest rate into simple interest rate and compound interest rate. So the story will start from actually compound interest rate. Okay, so first of all is the simple interest rate. Simple interest rate means if you have 100 today and you have earned 5%, and it means after 1 year you are going to get 105. Okay, so if you want to invest for the next period, so this is for period 1, if you want to invest for the second period, so your still 100 would be invested. Okay, not 105. So it means you have a principal of 100. In 1 year you are going to earn 5. Okay, so after 1 year your earning would be 105. But for if you are investing in the second period, you are not investing actually 105. It means you are not adding your interest that you earn. Okay, so it's you are not doing principal plus interest amount that you got. In fact, you are only investing your principals. Okay, so interest is not reinvested. So you are investing 100, not 105. So interest is not reinvested. Okay, so that is called a simple interest rate. While the compound interest rate means if you have in period 1, if you have earned 105, so next time your 105 will be invested at the rate of 5%, not 5, not 100. Okay, so you will get more return because your investment is now 105, previously it was just 100. So compound mean interest on interest earned, so 5% on 5. So let's see an example. Interest earned during the investment period is not reinvested. As you see in the previous first example, 100 would keep on being invested. Okay, interest is calculated only on the principal amount borrowed or invested, thus same for each period. So whether you invest for 1 period, 2 period, 3 period, you are going to get 5, 5 and 5. Okay, so compound interest is the interest earned in one period is reinvested to grow at the same rate in the next period. So same rate mean 5%, for the next period mean 105 would be reinvested for second period. The effect of interest on interest, so you are going to get 5% on 5. For instance, so this is example for the simple interest rate. Consider an original principal of 100 for 2 years at 10% per year. So it means you have P is equal to 100 and interest rate is 10%. Okay, so normally I can write interest also, you can write R, no problem. Return or interest, same thing. okay. Then in period 1 you are going to get period 1, it is today, okay. Period 1 you are going to get 10 plus 100, so after 1 year you will have 120. In year 2 what will you have? You have 120 plus 10 again, so it would be, sorry, this is 110, so this is 110. So next period you have 110 plus 10 again, so it will be 120, okay. So addition of 10 every period, so total amount would be 100 plus 20, it would be 120. So for simple interest I can write it like this. So the amount would be equal to P naught, okay, plus P naught into R into N, okay. So it would be P naught 1 plus R into N. So if you solve this, it would be 100 1 plus, because this is for 2 periods, so we are going R is equal to 0.1, and how many periods? 2 periods, so your answer would be 120. So this is when we have simple interest rate, okay. However, when we have compound interest rate, it would be P is equal to P naught, P at time t, okay, sorry, P at today present value would be equal to P1 plus interest, or you can write I or R, no problem, power N. So we are actually doing multiplication. Instead of, if you see, it is just multiplied with number of periods, but we are going to take it to the subscript, okay, superscript. So you can use this formula here, but it means if you are going to use compounding, so it would be 100 1.1 power 2, it would be 121. So instead of 120, now you have 121, so the difference is $1. So it means this $1 you are getting due to the compound interest rate. How? Because in first period you earn $10, and then 10% on the $10, interest on interest is equal to 1, okay. So that is extra actually that you are getting. So that was just the classification of interest rates, and now in finance actually we carry compound interest rate, not simple interest rate, okay. So this is used for compounding and discounting. So it will be used for compounding and discounting. Compounding mean future value, discounting mean present value, okay. Now we will see, first of all we are going to see the compounding for a single cash flow, and then we are going to see single cash flow, and then we are going to see multiple cash flow, okay. So first of all we are going to see the future value and compounding. This is actually the formula that I just wrote. It is equal to FV, future value, is equal to C, cash flow, 1 plus R power N. So this is the same formula I just explained, and this factor is called the interest rate factor, okay, interest rate factor. Okay, if you see, this is a situation here. Suppose that you invest $1,000. It means $1,000, it's your present value. Invest mean you are doing it today, right? Today at a guaranteed fixed rate of 6%, interest rate is 6% for a period of 5 years. So we will have 1, 2, 3, 4, 5. So starting of the period 1, starting of the period 2, starting of the period 3, end of period 3, starting of period 4, end of period 4, starting of period 5, end of period 5, okay. So now we are going to find the what would be the future value at year 5. So it would be equal to FV C 1 plus R power N. So this would be equal to 1338.23. Okay, in this case we have actually single cash flow. Now we are going to see, because if you see in the single cash flow we have different components. We have different components here. Wait just a minute. Okay, if you see in this formula actually we have future value, present value, number of periods, and then we have interest rate. Okay, so in the next parts we are actually going to solve we have already solved compounding. Now we are going to solve n and solve for r. For instance, in this question you are not given n and you want to find n, you are not given r and you want to find r. So in next class we are actually solving these parts for single cash flow. Okay, the question is saying how long is the wait, means you need to find n. Okay, so if you deposit 5,000 today, this is the present value, in an account paying 10%, this is the interest rate. How long does it take to grow to 10,000? This is the future value. How long mean we need to find r. So that's a very simple case. FV is equal to PV 1 plus r power n. Okay, if you see the solution using the financial calculator, it's very easy. So in the financial calculator you are going to use negative 5,000 because it's in your investment, future value is given, interest rate is given, and just you need to compute n, that is 7.27. and also we can do it manually. So that is actually equal to future value is equal to, this formula is equal to future value is equal to PV 1 plus r power n. So PV is 10,000, FP is 10,000, PV is 5,000, and you can solve this, and we can take the log of 5,000 plus n log 1.1, so that is log of 10,000. So if you solve this, your answer would be 7.27. so that is just a simple mathematics. So in the first part, and we have solved this part, we got n. Next part we are going to solve for r in case interest rate is not given. Okay, in this question, if you see, if you invested 5,000 present value in the shares of a company 18 years, this is n ago, and today your investment is 50,000. This is your future value. What average annual rate of return did you earn on your investment? So we need to find r. If you use the financial calculator, so these are the commands that you can follow, but if you are solving it manually, so you can solve it by using simple mathematics, and that's easy. I think it doesn't require any explanation, that's already done there. Okay, in the first part we have explained how to calculate the future value, then we explain how to calculate n while if the information is given, and then we discussed how to find r. Now we are actually discussing our present value instead of future value. Now we are doing present value of a single cash flow. So that's a very simple formula. It is equal to FV is equal to PV 1 plus R power n. So we need to adjust the formula only, that is equal to FV 1 plus R power n. So that is actually a discount factor previously, when this is a compound factor. Okay, so this is called a discount factor. If you see, if you are calculating the future value, that would be called as compound factor. Okay, and if it is 1 divided by 1 plus r power n, it will become discount factor because it's in the denominator. Okay, so let's take an example. You are considering investing in a saving bond that will pay 15,000 in 10 years. So 15,000 in 10 years. So if the competitive market interest rate is 6%, what is the bonds worth today? Today means we need to find the present value. Okay, so that's a very simple thing. If you put the information in the formula, it would be this answer. Okay, please remember one point here. If you see in this statement 15,000 in 10 years, so it means after 10 year, right, at 10 year. So some questions give you 15,000 in each of the 10 year. When the question is saying each of the 10 years, then it means every year, that is 15,000. So in this question, please make sure that you are directly given future value. This will be discussed when we will have each, the word each or every year, so that will become annuity. We will discuss it later. Okay, some students, they actually get confused whether the statement given is for the future value or whether some every year's cash flow is given. So please remember, in 10 years, if it is a cash flow, it would be every year, each year, so that would be the statement. So these are just a simple example again for the compounding and discounting. Suppose you have 8375.9 in the bank today. This is the present value, earning 6%. How much will you have 10 years from now? So that is the future value. And for the discounting, suppose you will be getting 15,000 in 10 years time from now. If the interest rate is 10%, what is the value of the money today? That is a present value. So if we go from left to right, that is compounding, and if we come from future to today or from right to left, that is called discounting. So this is the formula for the single cash flow, and this is the formula for the single cash flow. Now we have solved the future value and present value for single cash flow. In next topic we are going to solve it for the multiple cash flow. Okay, if you see these, because we are discussing the present value of multiple cash flow, so we have multiple cash flows here, 1 2 3 4. If you see, these are variable cash flows, they are not equal, right? So they are not equal, but they are multiple cash flow. So we need to find the present value. So simple, that is our simple formula. From today to year 1, of course this is the future value, so we need to get it back to year 0 for year 1. From today, this is the future value again, so we have to get it back, and this from here, this is the future value, we have to get it back, and this is the future value from year 0. So it means we are going to find the present value, but for every single cash flow. Okay, so that's why we are going to apply the formula of single cash flow discount factor or present value factor, that was actually equal to 1 plus r power n to different cash flows. So same, actually we are applying the present value formula for every single cash flow. Okay, so this is just a simple explanation, you can see that, and you have to add all of them to get the present value. Okay, so present value of all the cash flow. Okay, let's take an example. You need to purchase a Honda Accord. You decided to borrow the required money from HSBC Bank and promise to pay back in 4 payments during the next 4 years. Okay, the bank requested you to pay them back with an interest rate of 6% per annum every year based on your earnings and living expenses. You plan to pay them 5,000 in the first year 5,000, 7,000 second year, 7,000 third year, and 10,000 in year last year. Okay, calculate how much can you borrow now. Okay, borrow now means we need to find the present value to settle this loan according to your repayment plan. So this is the cash flow 1, cash flow 2, cash flow 3, and cash flow 4. Simply we are going to find the present value, and it would be 0. 0 mean present value today or now. Okay, so you need to add them all, so that would be the present value of multiple cash flow. Okay, now similarly for the multiple cash flow, we found the present value. Now we can also find the future value. So that's a very simple case. Simple, for the single cash flow it was equal to present value 1 plus r power n, right? But because now we have multiple cash flows, so we are replacing this p into different cash flows here, right? So we need to adjust the formula and then add them all. So present value, future value interest factor, future value interest factor, future value interest factor. So if you see this question, suppose that you deposit at the end of each year for next 4 years, every year 5,000, 8,000, 8,000, and 10,000, and the interest rate is 6% per annum. So these are actually your payments. How much money will you have at the end of 4 years? At the end of 4 years we need to find here. Okay, so we need to find the future value. So first of all would be, we need to take this value to year 4. So 1, period 1, period 2, period 3. So this amount would be taken to the future for 3 periods. Students normally they make mistake, they take 4 3 2 1. Don't do that, because the first payment is here 50. If the first payment is here, of course it would be first would be taken for the 4 periods, but this payment is starting in year 1. So how many periods do we need to take it for? The 1 2 and 3. But if you want to calculate the present value, we will take it for year 1. Okay, just 1 period. Similarly for this amount, it would go 1 and 2. Okay, so the first would be 3, then 2, and then 1. Okay, so 1 and 2, and this would be used for 1, and this would, we don't need any compounding because it's already at year 4. So that's why you can see it's 10,000. Even if you use 1.06 power 0, answer would be 1. So that's why you can see it's 10,000. Okay, so the answer would be this answer for the multiple cash flow. This is how we find future value.